Do you want to experience the amazing world underneath the ocean? But a submarine seems like kind of a big commitment right now? Then this story is for you. Our next guest is going to show us the secret science behind scuba. Have you ever wanted to live underwater, swim with the dolphins, talk to turtles, and maybe even see Jason Momoa in his element? We're still a ways from sprouting gills and living that dream. But with specialized equipment known as scuba gear, you too can get close to coral reefs, see shipwrecks, or even look for buried pirate treasure. To learn the science behind scuba, we're meeting with Charlotte Mausolf, aka Mama Ocean. She's guided hundreds of students as they learn how to explore beneath the ocean's surface.
I want to be a part of people changing how they feel about the ocean. I wanted to give people the opportunity to do something that really inspires them.
Today, she's here to teach us how to live like the fishes. But first,
I better get in a uniform. Let's get started with the basics.
Scuba stands for self-contained underwater breathing apparatus. And it takes a whole lot of gear to make scuba a reality.
We have a tank, we have our regulator system, and we have our BCD.
We start with the air tank, full of highly pressurized, breathable gases.
So our normal air is 21% oxygen and 79% nitrogen, which is in the tank. But we can't take high pressure air directly into our lungs, so how do we take it from here to here? This is a regulator. This takes high pressure air into ambient so that we can breathe normally, like we're on the surface. So no matter what depths, we are still breathing at the same rate as if we were on the surface.
Correctly pressurizing the diver's air is important, not just for breathing, but also for floating.
When we're diving, we don't want to be at the surface and we don't want to be hitting the ground. We want to be right in the middle of that, so we're able to see everything without destroying any of the environment.
To achieve this perfect equilibrium, a diver relies on another tool in their arsenal.
This is a BCD. It's a buoyancy control device, and this is what we put on to hold everything together, the tank and the regulator system, as well as our inflator hose, which helps us ascend and descend.
A BCD will use air to inflate or deflate, allowing a diver to control where in the water column they sit. As divers move deeper down the water column, the pressure around them increases, condensing the gases in their gear and bodies. This inverse relationship is known as Boyles Law of gases.
Let me show you what I mean. So this is a jar with a balloon in it, and this is a bicycle pump. So what I'm going to do is I'm going to push the bicycle pump and increase the pressure. And as we can see, the volume of the balloon is slowly decreasing.
One effect of Boyle's Law, at lower depths, the nitrogen in the diver's air tank is absorbed into their body at a faster rate than at the surface. Coming up to land full of excess nitrogen can cause pain, fatigue, and in extreme cases, death.
So as we ascend, we want to make sure we're having a slow ascent rate. At the end of our dive, we do what's called a 3-minute safety stop. And so what helps actually is take out the excess nitrogen that has been built up into our body.
But it's not just the gear a diver carries that matters. What they wear is important too.
We want to be able to see why we're diving, right? But did you ever notice that things look much bigger underwater than they do above?
That's because of a scientific principle known as refraction, when light waves bend as they move from air to water.
Refraction causes objects to appear 33% closer or larger. That's why objects or fish seem so much bigger in the water.
Scuba divers must learn to compensate for this distortion as they navigate around underwater ecosystems. For Mama Ocean, educating others about the science that helps her underwater makes the whole experience a little more magical.